Today's lesson is lesson 19, estimate roots. Remember to complete the work on a separate sheet of paper. Common Core State Standards we'll be covering today. We're going to talk about the mathematical practices. There's going to be 3 mathematical practices that we're focusing on. Number 1, make sense of problems and persevere in solving them. What this practice means is pretty much that you're going to try your best to continue to persevere to try to find the correct answer. Don't give up. Okay. Mathematical practice number 3, construct viable arguments and critique the reasoning of others. And number 4, model with mathematics. What will we learn today? 2, estimate square roots and cube roots to the nearest integer. Now, why would we need this? We would need this so that we wouldn't have to use a calculator at all times, but just keep in mind that even when you're estimating, if you still want to use a calculator, you may. So we're going to be estimating square and cube roots. And here's an example. You know that the square root of 8 is not a whole number because 8 is not a perfect square. We talked about perfect squares in lesson 8. The number line below shows that the square root of 8 is between 2 and 3. Since 8 is closer to 9 than to 4, the best whole number estimate for the square root of 8 is 3. Again, we're estimating, so we're going to be using whole numbers. Here is the list that I showed in lesson 1.8 of perfect squares and of perfect cubes. It's here for your reference so that you can refer back to if needed. Our first example tells us to estimate the square root of 83 to the nearest integer. So I know that square root of 83 is pretty close to the square root of 81, only 2 places to the left. We know that the square root of 81 is 9. So to estimate the square root of 83, we're going to say approximately 9. Example 2. Estimate the cube root of 320 to the nearest integer. Okay, with cube roots, it could get a little bit trickier. But what I'm going to do, instead of using a calculator in this instance, I'm going to use the guess and check. So let's go, let's start with 6. 6 times 6 times 6. So let's see what gives me, what I get with 6 to the 3rd power. 6 times 6, 36. 36 times 6, 216. That's still pretty far from 320. Let's try 7 times 7 times 7. 7 times 7, 49. 49 times 7, 343. So the best estimate for the cube root of 320 would be 7. Real world example. Wyatt wants to fence in a square portion of the yard to make a play area for his new puppy. The area covered is 2 square meters. How much fencing should Wyatt buy? So the fencing is obviously going to be around the play area or the perimeter. And right now we have one side as square root of 2 meters and the other side as square root of 2 meters. So let's think of square root of 2. The square root of 2 is going to fall between the perfect square 1 and the perfect square 4. I know the square root of 1 is 1. The square root of 4 is 2. Square root of 2 is going to be closer to 1. But in this instance, we don't want to leave it at 1. So I'm going to say, let's try 1.25. Okay. So in order to find the perimeter, I take a side, which is 1.25 times 4. 1.25 times 4, let's work that out. 5 times 4, 20. 4 times 2 plus 2 is 10. So we can say 4 plus 1, 5. So we're going to, Wyatt is going to need approximately, or about, 5 meters of fencing.
Estimating square roots. A golden rectangle is a special rectangle found in architecture and nature. One example from nature is a nautilus shell. In any golden rectangle, the length of the longer side divided by the length of the shorter side is equal to 1 plus the square root of 5 divided by 2. Estimate this value as a decimal. The first thing we need to do is estimate the value of the square root of 5. The largest perfect square less than 5 is 4, and the smallest perfect square greater than 5 is 9. So write the inequality 4 is less than 5 is less than 9. Next, find the square root of each number. The square root of 4 is 2. The square root of 5 is square root of 5, and the square root of 9 is 3. The square root of 5 is between 2 and 3. Since 5 is closer to 4 than 9, the best whole number estimate for the square root of 5 is 2. Let's use this value to evaluate the expression. 1 plus the square root of 5 all over 2 is approximately equal to 1 plus 2 all over 2, or 1.5. So in a golden rectangle, the length divided by the width is about 1.5.